the next most important concept or the component of STL is algorithms, right. So, we say these three are linked here: containers, algorithms and iterators. So, container are the data structures which store the data. Algorithms are the functions which we apply on these containers. To apply algorithm, iterator helps us in applying these algorithms. Okay, iterator helps us. I kind of, you can say, it's a mediator between containers and algorithms. Iterators helps us to talk between these two, containers and algorithms. Okay, so algorithm are the functions which we can apply on the containers with the support of iterators. Okay, so let's study different types of algorithms what we have in C++. So, they offer a wide range of functions to perform common operations on data, right. This function implement the most efficient version of the algorithm for tasks such as sorting, searching, modifying and manipulating the data in containers, right. These are the core. Actually, algorithms are the core of STL. Anyhow, all three are very important, but this is actually which adds flavor to the containers or the STL concept. Okay. So, STL algorithms are defined in algorithm, and some of them are defined in algorithm, some of them defined in numerical header file. Okay. So, by default you have to include algorithm, and for some we need numeric header file also. Okay. So, based on category there are two types of algorithms: manipulative, non-manipulative. Manipulative means it manipulates the data. Example is sort, or you can take swap. Swap manipulates the data, meaning if I write swap a comma b, the values are interchanged. Non-manipulative, they return something, they are useful just for printing. They are useful just for printing. I think you might have studied about string functions, right. We are having some function like upper, we are having something to upper, not upper, sorry, str upr function exists and to upper exist. Okay. So, this str upr function converts the string to uppercase, and it does not actually modify the existing string. Suppose I have char ch of some 10 is equal to hello. When I use str upr of ch, it only returns the uppercase string, but it does not modifies the existing array. It does not modifies the existing array, right. To upper means if there is a character c, small c, it makes that to capital C. It modifies the content. Okay. Here it is not modifying the actual content, it is converting and giving it to you, whereas here it is converting and modifying the in memory. So, this is not touching anything in memory, this is touching in memory. Based on that only we are having manipulative, non-manipulative algorithms. Let us see the manipulative algorithms, right. See, manipulative algorithms perform operations that modifies the elements of the given container or rearrange their order. Means they touch the memory, they go to the memory location of that variable or the container, they change the locations of the values, or they do some modifications in the data which is present in the containers. Those are manipulative algorithms. Non-manipulative, they do not touch the original data, they copy that into some other variable and do some operation. This is the best example to understand: string upper and to upper, right. String upper does not modifies the actual content, so it is a non-manipulative algorithm, right. So, let us explore few very important algorithms in STL. So, in that the first category is manipulative algorithms. So, what are these manipulative algorithms? So, the first one is copy, right. So, copies a specific number of elements from one range to the another. Okay. So, from one vector v1 there are some certain elements, you want to copy some elements. v1 has 1 to 10 elements, I want to copy 2 to 5 elements into v2, copying only few elements, or otherwise I will say contents of v1 can be copied into v2 using this copy function. Along with that, it has an additional feature that it can copy a given range of values from v1 into v2. V1 has 10 values, V2 are having no, I want to copy only few set of elements from V1 into V2, I can use copy, right. Next one is fill. So, it will fill all the values by with the default value. Okay. So, we will see all of them with examples and detailed syntaxes. So, I will just quickly go through them. Transform, right, it will applies a function to each element in a range and stores the result. Okay. What does transform does? If you are having an array A of 5, you are having some certain elements in that. I want to add plus 5 to all those elements, that can be done using transform. I want to subtract minus 1 from all the elements, can be done using transform. Replace a specific value with a new value. Swap, exchange the values of two variables. Reverse, arrange the elements in the reverse order. Rotate, this is the most powerful function in STL. Okay. Rotate, because there are a lot of problems which can be solved using rotate. If you see so many previous placement questions or some important or classical programming questions, if you are using STL, you can use rotate function and make your programming very, very easy. Next, remove, right. So, this will remove a specific element, whatever you give. Unique, removes consecutive duplicate elements, right. So, these are very important manipulative algorithms. Let us see each of them in detail. The first one, copy. Okay. See the example first, then we will go to the syntaxes and the explanation, right. So, I have a vector here, vector int v1, it has some elements, it has 1, 5, 7, 3, 8, 3. Okay. Next, I have created another vector v2, 6, I have created another vector v2, 6, we can give like this v2 of 6, right. So, I have created another vector v2. Now, I wrote the syntax here, you see, copy, the command is simple, copy, syntax, see, iterator 1, end starting iterator, end iterator and starting iterator of second, meaning you have to give the starting, this is v1, v2 is empty for now, v2 is empty for now, right. So, copy, you have to give in v1, which one, from where to where you want to copy, in v1 which index to which index you want to copy, that you have to tell. So, v1 dot starting, that is begin, I want to copy from begin. Then in v1 I want to copy from begin plus 3, meaning first 3 elements, here I have to give plus 4, first 4 elements I want to copy. Where you want to copy, in v2 where you want to copy those elements, from v2 begin, v2 dot begin. Okay. It means in v1 I am giving the starting index, I am giving the ending index, I am telling copy these set of elements into v2. So, v2 becomes 1, 5, 7, 3. What about remaining 2 in v2? We set 6 here, no, remaining 2 will be zeros, right. So, this is about copy function. We can copy the content of one container to another container. It can be array, it can be list, okay, it can be any container. You take it any container, what we have seen in sequence containers can be applied here for this copy function, right. So, once again see this, I am having a vector v1 and I am having another vector v2, right. I am using copy function. What is the syntax? In vector v1, what is the starting index and what is the ending index in vector v1, and where do you want to copy these set of elements, from which location you want to copy those elements into v2, that is the third one, right. So, this generic copy function is used to copy a range of elements from one container to the another. What is start iterator 1? The pointer to the beginning of the source container from where elements have to be started copying. End iterator means pointer to the end of the source container till where elements have to be copied. Start iterator 2, pointer to the beginning of the destination container to where elements have to be started copying. Okay. To where should I copy those elements? Into v2. This is the syntax of copy algorithm. Okay. This is very powerful and very important in problem solving, right. After learning this STL library and all these algorithms, iterators and the containers, if you go and see solve some problem, simply search in internet, your approach of solving the problem will become easy and interesting by using STL libraries. right. So, this is about the first function copy. It copies the content. See, suppose you want to copy all the elements of V1 into V2. What should I write here? I should write copy V1 dot begin, comma V1 dot begin plus 6 I have to tell here, because I want to copy all 6 elements. I want to copy all 6 elements. Then you have to give plus 6 here. Okay, V1 dot begin plus 6, then V2 dot begin. That is it. This will copy all those 6 elements from V1 into V2, right. Very powerful and useful algorithm, copy. Let us see the next one, fill. Okay, I created an array. I created an array int comma 6 with variable a. Okay, I am creating an array STL like this with size 6. I want to make all those elements in the array, right. I want to make all those elements of the array to be 0. So, you can simply write a dot fill of 0. We have seen this already, right. So, this is one algorithm which we can use to fill all the values in the array with zeros, a dot fill zeros, right. So, this fill also has a different syntax here. Either you can use like this for array, or if you want to use it for any container, then you have to follow this syntax, right. What is the syntax here? You see. So, you see this example here. I have created an array of size 10, right. Now, I want to fill this array A of 10 with a default value. What to do here? What is the syntax of this fill? Fill the starting, why A, the starting address, then how many elements do I want to fill? That is A plus 10. I want to fill 10 elements. With which value you want to fill? I want to fill all the values with 4. I want to fill all the values with 4, right. So, this is about the fill function. Now, what is the output here? For int I equals 0, I less than 10, I plus plus a of I. A of I means it will give 4 10 times. Why? From the beginning till a plus 10, I am giving 4, right. So, it is like this. You are having an array A of 10, still you can give like this, fill a comma a plus 3 comma 0. Okay, you can give like this, then fill a plus 3, right, a plus 7 comma 1. What do you think will happen here? First 3 will be zeros, next 3 will be ones. First 3 will be zeros, next 3 will be ones. Like this you can fill the array. So, what is this? The fill function assigns the value val, okay, to all the elements in the range begin to end. See, begin is included, but end is not included. Mathematical notation, I think you are aware. This means inclusive of both A and B. This means A is included and B is not included, B minus 1 is included. This means A plus 1 is included, not A, but B is included. This A comma B means except A and B, remaining all the elements in between, right. So, we are using this mathematical notation here. So, to representing range. So, from begin till the end, where begin is the initial position, end is the last position. That is why we are adding plus n here, array plus 10 we are telling, because I want to fill all the elements, right. So, this is notice carefully that begin is included in the range, but end is not included in the range. So, we are giving plus 10 here. Okay. So, this is another important manipulative algorithm we have in STL, that is fill. It will fill with the default values. Third one, transform. What is this function? Transform, right. So, very important one. What is this transform function? It is a built-in STL function used to apply the given operation to a range of elements and store the result in the another range. Okay. We will come back to the syntax. Let us go to the example and try to understand about this transform. Then we will come and study these syntaxes to make our programming easy. See, transform function to decrement every value of array by 5. I have an array with me. I want to transform that array. What operation I want to do in that? I want to reduce all the value of every value of the array by 5. Okay. So, see example here. I am having an array of 5 with elements 6, 7, 8, 9, 10. Now I am calculating the size number of elements, that is n. I am creating another array AR of 2. This is my A1. I am creating another array A2. See the syntax of transform function. I am creating another function A2. Transform function, transform, okay, A1 comma, which range you want, A1 comma, A1 plus n, the total number of elements, comma, right? And where do you want to store those transformed elements? Into A2 array. I want to store them into A2 array. You give here A2 comma, then you have to write this, since it's an array, you have to mention it like this. This is a copy variable actually. When we study iterators, we will understand this much better. Okay, then you open return A minus 5, return A minus 5. This is the syntax. What it is doing, you know, this indicates this is an iterator actually. This is an iterator logic. We will study this. Square brackets like this, in bracket A, meaning in the source array A1, take each element into A, do minus 5 and store it back in A2. Okay, take each element from A1, copy that into A, do A minus 5, store it back into A2. How long should I do this? Until A1 plus n, that is all the elements of the A1 array, right? So this is the syntax of transform. Okay, so transform actually, what we are doing here, we are changing only one container. That's why we are having two here, for unary operation, for binary operation. So this can be considered as a unary operator. Why? I am applying that on a single variable A, that is container. I am applying that on a single container A. That's why this is a unary operator. Okay, see the syntax once again, transform that A1 array from the beginning till the end and copy them into A2, then copy the array variables into a normal variable A, then open bracket, return A minus 5, close bracket and close. This is the syntax of transform function, right? Let us see another example. For adding each element of vector with another vector elements, here it is binary. Why? Because V1 plus V2 I am doing. V1 plus V2, I am applying them on two different vectors. Here it was only one variable A plus 5 I was doing, sorry, I was decrementing, no, it is minus 5. This is with the constant, single container minus a constant. Here between two different containers, V1 plus V2. So this is binary transform. So again, see, I have a vector V1 with values 6, 7, 8, 9, 10, vector V2 with 1, 4, some values in the vector V1 and V2. Then I am calculating another vector V, I am taking a temporary vector V with V1 dot size as the size of this vector V1 dot size means it is 5. Then what is the transform function here? You see, transform from vector V1 dot begin, from the beginning of vector V1, comma V1 till V1 end, from V2 dot begin, comma V2, right, V2 dot begin, from beginning here in V2, but V1 from beginning till the end, V2 from beginning, right. Then store that in V1 dot begin, store that result in the new vector V from the beginning. Then what is the logic here? Square int A comma int B, copy the elements of V1 begin into A, V2 begin into B, add them, that is why I am writing return A plus B, store the result in V dot begin, store the result in V dot begin, right. How long should I repeat this? Until you reach V1 dot end, until you reach V1 dot end, keep copying the elements, right. So transform function, this is on binary operation here using two different vectors V1, V2, and I am using a temporary vector V. Syntax is very clear, V1 dot begin, from V1 dot begin till V1 dot end, that is vector V1, from V2 dot begin, take each element from V2 dot begin, apply this addition operation, store the result back in V dot begin, right. So this is about transform operation. Now see the syntax here, right. Transform first, last, the result and the operation, okay, right, which operation you want to be performed. Then first, last, first one, this is vector v1, this is vector v2, where I have to store the result and the operation which I want to perform. That is what the description is given here, right. First indicates the iterator of the first element, last till the end of the element, first one the new element of the second vector, result where I want to store the output, op1, op2 are the operations. What does this returns? Returns an iterator to element just after the last element of the output range. So, after performing it gives the result. So, what will this no, here in this case what will that V contain summation of these two into this V, right. So, this is about transform no algorithm what we have in STL. So, till now we have studied copy, fill and transform, right. The next important algorithm is replace, right. So, what we do here, replaces new value to all the elements in the range, okay, compared to the old value, right. Let me show you an example and then come back there. So, I have an array here with values 10, 20, 30, 30, 20, 10, 10, 20, okay. I am calculating the size, I am giving two, I am having old value as 20, new value as 99, old value as 20, new value as 99. So, replace syntax is replace, okay, where you want to replace in the array A, how long you want to replace till the end, that is what ARR plus n, what is the old value, you give old value, comma you give the new value, that is it, this is the syntax, okay. ARR from the beginning till the end. See, in all these functions if you observe, they are giving as an additional privilege whether you want to update only till half of the array or till the whole array, that can be played with this end. This is the beginning, this is the end. So, if you want to change only till first half, in the first half replace every element with 20, replace 20 with 30, 30 with 20, everything can be done, right. You can play with this, that is why they are manipulative algorithms, okay. So, here ARR plus n means from the beginning till the end, wherever there is old value put new value. So, what is my old value 22, what is my new value 99. So, this statement you say replace ARR plus n, old value, new value. After that what will this array become? This 20 will become 99, here also it will become 99, this will become 99, that is the program, okay. This is replace. So, replacing one value with the other value in any container, you can do this in any container, okay. From the beginning till the end, old value and new value is the syntax. See here, that is what assigns new value to all the elements in the range first to last. This is my choice, I can give that or I can reduce that compared to old value. This the function use operator double equal to compare the individual elements of the old value. It is internally checking, double equal to, right, this old value, is this is equal to 20, is 20 is equal to 20, yes, replace, 30 is equal to 20, no, equal to 20, no, like this it is checking and replacing the values. Syntax is replace the first indicator, the last indicator, the old value and the new value, right. This function does not return anything, but it replaces the elements in the container. If the element is found, only then it will replace, otherwise remain unchanged. Suppose you gave here old value as maybe 15 and new value as 50, there is no 15 in the given array, so it does not changes anything, right. So, this is one simple example to explain replace, the most important one, replace. Let us go to the next one and the easiest one, swap. It does not require much explanation. Swap AB, it will swap those values. In C programming or in C++ also, without using STL, we have to write the logic T equal to A equal to B equal to T. But here you simply use the function swap. Swap AB, include the header file, algorithm, and your programming becomes easy, right. Swap AB, it does not require much explanation, it will swap the values of A and B. Next, reverse, it is also self explanatory, it reverses the order of elements in the given range, okay. Here you can play, sometimes there are so many programming questions, they will say, suppose I have elements like this, they will say reverse the first half first half of elements, right. So you want 4 3 2 1 5 6 7 normally, or sometimes they will say reverse the second half. So you want your first 1 2 3 like this, then 7 6 5 4. All these programming questions which are very important and useful for placements, you can use this STL to make it easy. Okay. So see, reversing it is very difficult without using this STL. If you want to do, you have to do you have to write lot of logic there. Okay. So this reverse function reverse the order of elements. If you say from beginning to the end, it will reverse in the order. Okay. See, the range is used first last, which contains all the elements between first and last, including the element pointed by the first but not by the last. Always it is like that. I think in Python programming also we know about range. When I use the function range of 10 means it is only till 0 to 9. It is not including the 10th one. Same way it is here. Okay. So see this example, I am having 10, 11, 12, 13, 14, 15, 16, 17. What I have done here, reverse v dot begin plus 5, meaning from the fifth index, that is index is 0, 1, 2, 3, 4, 5, 6, 7. From the fifth index, v dot begin plus 8 till the last index. So I want to reverse only these 3 in the array. So this remains same. You see 17, 16, 15 has come. We are reversing only last 3 elements. Okay. That is the specialty of this reverse function. You can reverse in a given range, whatever range you want. You can make your programming very easy using this STL. Okay, right. I hope you understood. I am giving the index from where I have to begin till where I have to end. Only those things will be reversed in the given array. Next one, rotate. The most powerful function what we have is rotate. Very, very important and very much useful in placement questions, that is rotate. What is this rotate function? Right. It rotates the order of elements in the range, first and last both inclusive in such a way that the element pointed by the middle becomes the new first element. Okay. Let us see example and then come to the syntaxes. See here, right. I gave the input 1, 2, 3, 4, 5, 6, 7, 8 normally. Okay. Now we are rotating by the third position. Rotate, there are two types, rotate left and rotate right. So if there is element like this 1, 2, 3, 4, 5, if I say rotate this by 2 left, rotate 2 left means these 2 will come here, it becomes 5, 4, right. Rotate right means these 2 elements will come this side, it becomes 3, 4, 5, 1, 2 like this. Okay. Rotating the elements. I think you are aware of one of the very popular placement question, right. Given a string A, B, C, B, A, something like this. Okay. So how many rotations I should do in this to convert this to a palindrome string? Okay. How many rotations I should do? Here it is again like this if I have. Okay. How many rotations should I do on this to make this a palindrome? So it is 1 rotate left. You can do 1 rotate left. So this A will come here, it becomes palindrome. A, B, C, B, A. It becomes palindrome. Very, very popular question. For that you can use this rotate function, right. So rotated the third position. See 1, 2, 3 I am bringing towards right side. 1, 2, 3 like this. Left side means you see I have an array like this. I am rotating from fifth to the left side. So these 3 I am bringing towards left side. Okay. Rotate right, rotate left. Very, very important algorithm. So what is the syntax? Forward iterator first, the middle and the last. Okay. 3 things we have to specify here, right. First and last are the initial and final positions. Okay. So in this case, the syntax here would have been rotate the array A plus array A till which location you want. Where do you want to rotate it? Right. See, I want to rotate here first 3 to right. So I want to rotate A plus 3 comma A plus n, the beginning, the end and the middle. So these 3 are shifted this side. Okay. the middle pointing to the element within the range that is moved to the first position in the range. This number which you are giving here a plus 3 will be moved to the first position. Same way all things will come front, these 3 will go back. Okay. So, there are two types of rotations. Left and right rotation, right. So, to rotate left we need to add the vector index. For example, if you want to rotate vector left 3 times, the third index of the vector becomes the first element. Okay. When you want to rotate right 3 times, the third element index becomes the first element. I will show you example here. See how do you implement rotate left and rotate right. Here this is rotate right. So, what I have to give the rotate function with the starting a plus 3 and a plus n. What will happen here? From beginning till the end, the a plus third element should come in the first position. From here bring everything this side. Okay. Reverse case, you see, rotate, here which element should be become first, that has to be given. Somebody says rotate left by 3 if they say. So, you have to give a here, then what is the size of this a, what is the size of this complete array? That size a dot size minus the value which I want to rotate, that is a dot begin plus 5, like this. What has happened? A dot size minus a begin plus 5. So, till here, that one I want to make it first. So, it becomes rotate left in that case, and a plus n as usual, right. So, because why are we doing this? Because this number 5, this number is given as input to rotate, right. So, this is about the important function rotate algorithm, right. We can do left and right rotates, very powerful algorithm in STL. And the one is remove, the next one is remove, right. So, again let us see an example and try to understand this. Program to remove an element from the array. So, I have an array with me, I am calculating its size, then I am using the remove, starting, then the end and 3. From beginning till the end, remove 3 from the array. This remove function, this remove algorithm will remove this number 3. Okay, it will remove this number 3 from the given array, right. So, see here, it is used to remove an element from the specified range of elements. This can be for vectors, DQs, arrays, list, everything we can use this. Remove first location, the last location and the value to be deleted from the given container, right. So, what is this? See here, I am having this, I am saying remove from the beginning till the end, remove 3. So, this becomes 1, 2, 4, 5, 6, 7, 8. 3 is removed from the array, that will be the output here. But since I am removing, I am maintaining a pointer here, because it is returning a new array, it is returning a new location. Okay, it is returning a new location, NE, that is what it is saying here. So, NS is one new variable, NE minus ARR. So, this address minus this address we are subtracting. Why? See the very important point, how does remove is actually returning the last element's address, not the first element. Remove is returning the last element's address. I know the first element address, you subtract this, you get the number of elements in between, right. So, that is the logic of remove. So, let us see the syntax here. This range can be whole or part of vectors. So, returns an iterator to the new end of the modified range, that only contains the elements not to be deleted. Okay. If there are no elements to be deleted, returns iterator to the container's end. Suppose I am deleting, I am saying here instead of 3 I am saying 11. So, this NE will point to 8, it will point to the end of the container, then this NS will be 0. Okay, NS will be 0, like that we can link that elements here. So, this is about the algorithm remove. And the last and the most important one, unique. This is one of the last manipulative algorithms, unique. Let us see an example and then come to this theoretical part. See this example. I am having a vector with so many elements. In this, there are some consecutive repeated numbers. There are some consecutive repeated numbers. For example, 1 1, 3 3 3, 3 3 7 7, right. Unique is a really a unique function which will remove the consecutive repeated elements, This is very, very powerful, because you see a lot of placement questions, they ask you remove the duplicate elements from the array. Very popular question. Or which is the first repeated duplicate element? Which element is having first repeated duplicate element? Very powerful algorithm, unique. See, the output of this program after writing unique will be 1, then only 1 3, then 10, then 1, then 3 7 8. You may ask me, sir, 3 is repeated here and here. No, only wherever they are consecutive, there it reduces. Okay, only wherever they are consecutive, there it reduces. Let's see this, right. It is used to remove duplicates of any element present consecutively in a range. Okay, so here there are duplicates. 1 1 is duplicate, so this is removed. Then 3 3 3, there are duplicates, these two are removed. Okay, right. It performs this task for all the subgroups present in the range having the same element present consecutively. If the element presents are consecutive, only then it removes. Okay, it does not delete all the duplicate elements, but it removes duplicacy by just replacing those. This is the internal logic, how it does, right. All the elements which are replaced are left in an unspecified state. Actually, what is the algorithm here, how it is working? See, 1 is there, okay, next one is 1, so this 3 is copied here, next is 3, this 3 is removed, this is removed, this 10 is copied here, so this 1 is copied here, then 3, this 3 is removed, this 7 is copied in this location. Like this, it copies in the previous locations. So if you see 1 1 3 3 3, 10 1 3 3, like this, no, we are having 7 7 8. So 1 comes here, then 3 comes here, then 10 comes here, then 1 again, then 3, then 7, then 8. So these elements are replaced with these elements. This one are remaining same unspecified state, they exist like that only in the array. Okay, they are not deleted, right, but we are maintaining this count, we are maintaining this range, right. So that is the use of this unique function, very, very powerful, right. Another interesting feature of this function is that it does not change the size of the container after deleting the elements. That's what I said. The array is not deleted, these elements remain same at the end, like this only, size does not decrements, right. It just returns a pointer pointing to the end of the container. Where the elements are ending, that pointer is given to us. Based on that, we have to resize the container and remove the garbage elements. Okay, maybe you can insert zeros at the end after that location, something you can do there, right. So see the program here, I am having a vector v, I am having a iterator here. So again, std is not required. Unique syntax is unique from beginning till the end. Okay, this is range I am giving here, from beginning till the end. Find out the duplicate elements and remove them. Okay, then I am resizing it. How I am resizing it? Using this IP. IP is a pointer which points to the last element, like this. It becomes 1 3 10 1 3 7 8. So 8 is here, that pointer is given to us with the IP. So I am calculating distance from the beginning till the IP distance. I am calculating, I am resizing the size of v. Then you normally print the elements, right. So this is about the unique algorithm. Okay, so we have seen so many important functions. We will quickly recall what we have studied in the manipulative functions, right. We have seen about copy, it copies the content from one into the other, right, in a range again. Then fill with some default value. Transform, you can do binary transformation or unary transformation, like adding 5 to all the elements of the array, replacing old with new value in all the containers, swapping value, reversing based on the index, rotation, left or right rotation, remove the elements in the given range, right, and unique, removes the duplicate elements from the given range. So these are few important manipulative algorithms in STL. Let us see some non-manipulative algorithms. So, non-manipulative algorithms are the type of algorithms that operate on elements in a range without altering their values or the order of elements. The original content is not impacted with this non-manipulative algorithms. Okay. First one, finding max element. Function is max underscore element. It finds the maximum element. Min underscore element gives the minimum element. Accumulate finds the sum of elements in a given range. Accumulate sum of elements of a in an array, you want to find out sum of all the elements, you can use accumulate function. Count counts the occurrence of a given element in the range. From the beginning till the end, I want to count number of times a given number is appearing. Next, find returns an iterator to the first occurrence of an element in the range. You are having a vector or array with you, there are so many numbers, you are trying to say find of 3. The first appearance or the first occurrence of 3, it returns a pointer to that location. Next is permutation, checks if one range is a permutation of another. Is sorted, checks if the range is in non-decreasing order or not. Partial sum computes the cumulative sum of elements in a range, right. So, partial sum is very, very important. Cumulative sum, there is one more interesting placement question on this cumulative sum. Suppose you are given array 10, 20, 30, 40, 50, right. Print the cumulative average is one question. What is cumulative average? 10 will come as it is, then 10 plus 20 by 2, it is 15, then 10 plus 20 plus 30, 60 by 3, it is 20, then 10, 20, 30, 40, so it is 100 by 4, that is 25, then 150 by 5, so it becomes 30. This is the cumulative average. Now, there is one placement question which is previously asked on this basis, right. So, you can use these functions for doing that, right. I will repeat once again: max element to find out the maximum, minimum to min element to find the minimum element in the range, accumulate sum of all the elements in the given range, count a given element number of times it is appearing, find whether the element exists or not. If it exists, give its starting location, that is the pointer. Is permutation and is sorted, is the elements array sorted or not. Then partial sum computes the cumulative sum. Here what it will do, cumulative sum means like this. Cumulative sum will be 1, then 3, then 6, then 10, then 15 will be the output of this partial sum. That is cumulative. It is doing 1 as it is, then 1 plus 2 here, then 1 plus 2 plus 3 here, till 4 here and till 5 here, right. So, these are few non-manipulative algorithms in STL. Okay. So, with this we complete manipulative and non-manipulative algorithms. So, algorithms part is done with this function, right. So, we have to include algorithm header file. There are two types, manipulative, non-manipulative. We have seen different types of algorithms in STL.